Hi, morning everyone. I would thanks Andrew and Eddie for giving us the in-depth on our embedded products, the C2000, MSB M0, Wi-Fi, and so on and so forth. So this morning we talk about the embedded products on the digital world. So from now onwards, I will kind of change the gear a little bit. We go back, bring you guys back to the analog world, right? So I started with a very simple analog products, which is called the logics and the PLD and so on and so forth, right? So by the way, I'm Seng Chai Soh here. So I'm the sales guy from TI. So I'm located in Singapore, and my charter is actually to go after the Thailand market. So I think I've been seeing a lot of familiar face for the past 1 year and so. So you'll continue to see me in Thailand for the next couple of months. So I'll be coming to Thailand almost every month. So I'll be here this week, and 3 days later you'll see me again in Thailand and so on and so forth. Right? So this morning I'll just give you guys I would say a quick refresh on logics. I think most of you already know what logics all about. So nothing fantastic, just a refresh to let you know that TI, we still do logics, and what we have, what are our main investment and the new products. All right. So let me start with the so-called the logic portfolio, right? So in TI, so we have the 5 product family, which I put it over here. So we have buffer, driver, transceiver, right? So if you look at the just the general purpose transceiver itself, we are close to 400,000 products just on the general purpose transceiver, right? Of course, we have the inverting and non-inverting buffers and also drivers. So this is the first product family. And then the second one will be the very standard logic gates, the AND gate, NOR gate, exclusive, and so on and so forth, and also some of the translation gates, right? And the third one will be the very familiar flops, the D flip-flop, the JK, and the shift register, right? And the fourth one, which is very interesting, so this is a new area actually TI invested, the area called PLD, right? I think this is some area will be kind of a new to you, which I will introduce to you at the later on. And of course, the last product family, we call it very special logic. They're actually doing kind of digital marks, demarks, encoding and decoding. So if you look at our product space, the logic itself, we have 13,000 products. So remember what Eddie had mentioned in the morning, TI, we have 80,000 products for overall TI. So logic itself, we have 13,000. That's around 15 to 16% of our products. Right, so again, one of the key area when we look at the logic, right, we are focusing very much on the low power as well as the high speed. Okay, of course, it comes with various different packages. So, like what Eddie said in the morning, TI mission is to make sure we are able to give you products of a very good price in order for your product to go to market. So likewise for logic, right, our main mission is to be the most trusted supplier, right? So you'll see TI 30 years ago, and you'll see TI 30 years later. So we'll always be there to support you, right? And we want to make sure our logic go to every single one of you, right? Whether you use it now or use it later, please remember to use TI, all right? So that's our mission, okay? So in terms of the product, as I mentioned, so we are able to deliver one of those smallest packages in terms of size. Right, so some of these are even less than 1 mm squared in the Exxon packages, and also 35% smaller if you compare our latest packages in terms of SOT and a VSOP to a TSOP. All right, so in terms of the new voltage family, new product families, so we have the low voltage or low power. So our voltage can go as low as 0.8 volt and also to 1.8 volt. So these are the low voltage logic. And of course, the integrated solution, which I mentioned, which is the TIPLD. All right. So of course, the most important thing that we want to get to you is, of course, number one is delivery, right? We want to make sure you use our part and we are able to deliver you all the products. So as mentioned earlier, TI have a big investment of 5 billion a year in expanding the wafer fab as well as the assembly and test. So this is definitely something we do to make sure we deliver every single logic to you. So in terms of sourcing, again, like what Eddie mentioned, so we are always having a dual source strategy. So our logic don't just come from one assembly test. It can come from 2 or 3. right? Product portfolio, as a highlight, we have 13,000 products. And roadmap, we are always looking at a smaller solution and with a higher performance. And of course, TI.com. So this is an area whereby you can actually get a lot of the information as well as logic part from TI.com. All right. So I'll next move to the so-called our logic family. So we separate into what I call less than 3 channel CMOS and TTL output, right? So the key thing about this logic family, basically we can see is we have 6 product family where we call the LVC, which is the low voltage CMOS, and advanced high CMOS, and ACT, the advanced CMOS with the TTL compatible, and then the ultra low power and ultra low power and ultra high speed, and also the logic gate with the translation. So all these 6 product family we can actually apply across all the various standard logic gates, as well as the buffer, inverters, mux, and so on and so forth. All right. So this is for the less than 3 channel. So for logic family, there are more than 3 channel. You can see that it's expand beyond the 6 product family I mentioned just now, right? So we have the newer one called the LV-A. So this basically is a advanced product that is able to provide a better noise immunity. All right, and also, of course, the very legacy product we call the CD4000 that provide the widest voltage range, as well as the HCS and ACD, right? So these are another 8 or 9 product family to support all these various standard functions. Okay. So next, I'll move on some of the standard logic feature that we have with TI. So a very standard feature, which is the open drain output, and then the second one will be what I call the TTL compatible. So when you come across the TI part number AHC followed by a T, so the T basically tell you is TTL compatible. All right, and of course we also have the Smith trigger inputs. So whenever you see a HC with an S, so the S basically tell you you have a schematic trigger inputs. All right, and also some IO feature, ultra high speed, logic with voltage translation, and then the input clamp as well as some no output. So these are some of the standard feature that you can find in our logic products. So now I was just give you some insight into what we call, even in logic, we also provide so-called dual footprint. Right, you guys heard about dual source. So TI logic, we have a dual footprint. So what it meant, all right? So it's essentially a single PCB, we have a dual footprint on top, so that you can actually swap devices from, let's say, a T-SOP to SOT, so without changing the PCB. So of course, this one of the good thing about this is that in terms of shortage, right? So in the old design, maybe you're using a T-SOP. So out of nowhere, there's shortage T-SOP. So what you can do is quickly change it to your SOT package, because there's no need for you to change the PCB at all. So all this is what we meant by a dual footprint. Right, so the next few slides will basically share with you the various what I call the dual footprint in terms of those more than 3 channel. So when I say ladder here, it's basically talking about those deep frame, right? So this is a comparison of our smaller package we call the SOT versus the standard PW, which is a T-SOP. So you can look at this 14-pin T-SOP and a 16-pin T-SOP. So the space area for 14-pin, 16-pin, you can see is 36 and 43, right? So if you look at the what I call our SOT packages, you can see the saving of up to 50%, right? So we have 2 packages in a single PCB design. So this is what we meant by the dual footprint, right? So likewise for a bigger pin, which is a 20-pin T-SOP, right? So instead of the SOT, now we talk about using a VSOP, VSSOP, right? So we have a T-SOP and also a VSOP. So again, if you look at the space area utilized is around 60 mm squared, and saving of close to 35%, right, for a VSOP to the T-SOP. All right. And then for even the last 2 slides, we talk about more than 3 channel logic. So now we are talking about very simple 5-pin logic. So even for simple 5-pin logic, The very common one which you guys probably using are the SOT23, IC70, right? So we also have similar kind of what I call a dual footprint, right? So you can be designed using SC70, and eventually you can actually use the SOT23 can replace by SC70, right? Single PCB dual footprint. So likewise for these different packages, is the same concept, right? So for a small package, you also allow you to have a dual footprint. Right, so this one will be a more interesting one that even you can use a QFN into a TSOC. Right, so this is an example of a 40-pin TSOC and 16-pin SOC using just a QFN. So that's why we call is from a leaded to unleaded. Right, TSOC you know is with a lead frame, right, and the QFN is hidden below. So you can also do that, QFN to TSOC. Okay, so this is an example I just what I highlighted in the previous slide. So from the very legacy device that you guys been using, the SOIC, and you migrate to the TSOC, and eventually you will come to the even smaller packages. We call it the SOT or even the VSOC. So you can see the percentage of size decrease from SOIC all the way to SSOP from 75% to even 50%, right, as you do a comparison. So the IC is getting smaller and smaller in terms of the package. All right, so this is just a one pager on the package that I mentioned, SOD23 tin. So you can see that on the left, this is a standard TSOC. How big is this as compared to the newer package is how thin and narrow is it. So of course, that will not compromise in top performance. So you can see that actually the saving in space will actually give us even a lower power dissipation. Right, so this is for the TSOC. Then if you look at the VSOC versus the TSOC, so again on the left is the TSOC, right, as compared to a VSOC. Again, you can see the reduction in the size if you compare the two packages. Okay, so I move on to okay, this is just a recap of what I mentioned, the 6 product family across our logic family, right? The standard low voltage, we call it the LVC, and then the AC, and the ACT with the TTL compatible, and of course the one that I mentioned just now, when you see a S, meaning that the input are with a Smith trigger, right? So these are the so-called a newer product that come out from TI. And of course, the another one is called the multi-gates with the voltage translation. So for the next few slides, basically, I will share with you some of the common use case in terms of logics, right? So for example, in your design, you will come across a lot of signal timing or noise issue, right? So probably what we can do is to add in a Smith trigger function here, right? Is to correct the noise signal, or sometimes you may need a delay, right? Again, you just make use of the Smith trigger to generate a delay. And also, if your system need to generate a pulse on the rising or falling edge, so you also likewise can use a Smith trigger with an AND gate. So these are one of the few cases where I use of the Smith trigger, right, to encounter all these signal timing and also the noisy signal. All right. So the next one, we'll talk about the signal routing, right? So, for example, if you need to combine error signal to do a certain thing, right? So you can actually use a very simple NOR gate, OR gate to do the simple function. So likewise, if you have a multi-rail and you want to have just a single PG, the power good, right? So you're using an AND gate, or can use a NOR or OR gate to do a similar function, right? So this is a second use case. And then we come to the next use case, which is called the signal integrity, right? Whereby your signals, because of wrong routing, your signal strength is not there. Basically, you add in a buffer, right? So you can simply just add in a buffer, either a single buffer or dual buffer. And of course, again, because of long trace, you have very high capacitor line, and you want to overcome that. So basically, you're using a buffer, an auto buffer, or even the some of the auto bus. So these are typical some of the examples whereby you will use the logics. And likewise, if you are using MCU, you're running out of I/O pin. So again, you can use simple logic, for example, a shift register. Right, so in this use case, basically the process, you are using a shift register to drive an LED, right? So another case is you're using a shift register to drive a stepper motor. And then another one will be actually using a shift register to drive a 7/7 display, right? So and likewise, if you need to do some clock division, right? And you can actually make use of a D flip-flop to do either a clock division or multiple clock division. So this can be easily achieved by using a very simple D flip-flop. Okay, so that's the on the simple side, all the logics, just a refresh. I think it's nothing fantastic. So you guys have been using logic for many, many years. So right now I want to change the gear a little bit, something new from TI. We call it the programmable PLD. So again, this is not new to the industry, but something new to TI. Because TI have been doing a lot of the logic. So this is a new product area we actually invested. All right. So as I mentioned in the earlier slide, so this is a product area that we invested. Right, so what is the PLD? So we actually in TI we call it the TPLD. So T stands for TI. So Texas Instruments PLD. Right. So basically, I think all of us know that the PLD is basically integration of IC. Right. That is basically leveraged on our wide portfolio of logic and analog function, and then to provide the solution in a single chip. Right. So this is the fundamentals of doing the PLD. Okay. So as you already know, so we already have many discrete logic, and you guys have been using it, many of them. So we are now venturing into the so-called TI-PLD, right? So right now, our focus is strictly on the PLD, and of course, in terms of number of pins, it's less than 32 pins, and 100S of the logic elements, and we have various analog integration. They have comparators, voltage reference, and so on and so forth. And of course, provide you a very simple programming, right? Of course, the next level, we are talking about the CPLD and even to the FPGA. So these are the two areas that TI is not involved, right? So our focus right now is just a simple PLD, all right? So of course, the key challenge here is we're able to do the integration or combine up to 40% of a digital analog. So the benefit of it, of course, is you're able to reduce your PCB, and eventually is your overall BOM cost. So that's the ultimate goal of using a TI, using a PLD. Right, so what is so great about TI, right? So basically we offer our PLD in a very standard packages, SOT, QFN, and TSOC, and VSOC. So basically, and on top of that, of course, we will definitely want to provide you the lowest power as compared to our competitor. And on top of that, so our PLD are what I call automotive grade certified. We are Q1 grade, right? And we have actually having a extended temperature range from -40 to 125 degrees. So these are the value from TI. So of course, the development wise, I would say that it's quite straightforward, five key steps. So the number one, we always start with so-called the evaluation, right? So you guys will look at what we have in terms of our PLD portfolio. Then you get a EVM from us, the programmer, right? And then you download this what we call the interconnect studio to do the simulation evaluation. And then you look at the various training. So this is the first step as evaluation, right? Next, you move into what I call the customization, right? So basically, you need to understand what is your use case. You want to use it to do some power up or power down sequencing or some voltage control. Then you're making use of a lot of the example from us to do a start. And then you can do a simulation as well as doing a debug on time, right? So this is still under what I call the development phase, right? Then after that, you go into your prototyping. So when it comes to prototyping, right, again, you are using the standard EVM from GI and the programmer. So of course, the prototype will limit up to 50 pieces on doing a prototype. So you can actually, either you have permanently make it rounded, or you can still do a changing it. And of course, you can do download and configuration. So this is still under the so-called the prototype. Then we move on to the pre-production, right? Again, we can still make a lot of adjustment to your programming, and you're still able to make changes, right, on the prototype. So when it comes to the production, when you find us having design, right, so we will actually help you to do the production in a way that we also help you to program, and we don't charge you any adder, right? So there's no NRE involved, no licensing fee, and there's no programming cost, right? So these are the simple 5 steps from nothing to something from the TPLD, right? Okay, again, the benefit which I mentioned earlier. So the key one is definitely to reduce the design complexity, right? For many gates into a single IC, and of course that will translate into a cost saving, right? Of course, the product updates, and then the integration of many functions. There's no NRE, there's no adder when using TI solution, all right? So these are some of the typical use case of a PLD. So you can see that you can use in terms of the clock generation, PWM generation, as an analog comparator, delay generation, and power sequencing, as well as a multiple logic function, right? So the next few slides will show you some of the example use case. For example, in the power control, right? So in a circuit, if you are using a very complicated processor, typically you know that you need to do a certain power sequencing, right? So you cannot simply just tune in all the voltage and enable it work. So sometimes you need a power sequencing, as if you need to turn on the VCore 1.2 volt first, then followed by the peripheral 3.3, and eventually the 5 volt. So these are what I call the certain power sequencing you need to do for powering up and powering down, right? Of course, you can use a very complicated PMIC to do the function, right? So for us, there's no need. You just need to use a simple PLD to get the same goal, right? So for us, our PLD, we have an integrated counter and oscillator, and able to combine to support the power sequencing requirement. So a simple PLD can help you to do the power sequencing up and down, right? So this is one example. And then the second one will be what I call the timing flexibility, right? So in your design, maybe initial design, you only have one fixed frequency, but over time, you realize that you need to change your design. So you may need to have a multiple frequency, right? Of course, you can add in a lot of oscillator or other solution, but that's not the way to so-called expand your design. So you want to make it simple, again, just utilize the PLD from TI. So basically, you can see that we can make use of 2 switching frequency from our frequency generator as well as delay, right? So this is, can see that we have oscillator can support up to 1.5 meg, and we have many devices to meet their application requirement, right? Again, a simple PLD to do the multiple frequency. And then another use case is the PWM generation, right? Again, you try to make use of the PLD to do the PWM. So basically, our PLD is able to generate a 30K, and you can vary the duty cycle, 25%, 50%, or even up to 75%. Okay, and another one will be what I call the voltage monitoring. So I think you guys will be very puzzled why you need to use a PLD, right? So you can actually go to the off the market to just buy a simple SVS TPS 3809 can do the job. I think the good thing about this is that we are able to provide you a more integration, right? We have an integrate the analog comparator, digital element, and also the S detector. All right. So this is another usage as a voltage monitoring. And then of course the what I call the parallel application. So basically you combine a lot of the logics together, and want to have an output at the same time, or even have a multiple output. So again, we can actually make use of all the elements to do all the various logic functions in a single IC. Okay, so in terms of the our PLD, so this is something new. So currently we only have 3 products under the PLD. So you can see on the right, so the simplest one will be the so-called the 801, and followed by the 1201 and the 1202, right? So if you look at the common feature, so basically you can see that the voltage supply is 1.7 to a 5.5 volt, and it's a one-time programmable NBM, all right? And of course, if you look at the micro cell, we have a 2-bit, 3-bit, and even 4-bit logic elements, and flip-flops, pipe delay, counters, and so on and so forth, right? So let me go through the next slide. We'll actually give you a more detail on each of these products. So we start with 801 with the simplest. We only come with the 6 GPIO PLD. So we have a 2 or 3 or even 1 4-bit LUT, right? So this is a very simple one that doesn't have any analog comparator built in, right? So it's a very simple 8-pin or 10-pin in SOT package, right? So the next product is actually what we call the Chao1, right? So this is slightly higher than the 801. So we actually come with a 8-bit. We actually come with an 8 GPIO, all right? And of course, many of the LUTs. And right now, you can see that we have more analog component integrated. So we have the comparator, and we have also the voltage reference inside, and so on. And this will come in two different packages, the QFN and also the VSOP. Right, of course, the next higher tier we call the Chao2. So basically, this is come with the 10-pin, 10 GPIO PLD. All right. So again, come with all the various 2-bit, 4-bit, or 3-bit LUT. You can see that we have much more integration into these Chao2 devices. So even we have thrown in the serial communication, which is SPI or I2C. Right. So this come in the QFN as well as SOT packages. So these are the 3 products currently we have. Of course, you will definitely want to expand more, right, as we progress. Okay, so the next 2 slides will show you some of the what I call example, right? So this is an example of using a discrete solution to do a power sequencing as compared to TPLD, right? So if you look at discrete itself, you easily use up to close to 20 devices, right? And you look at the so-called the size occupied from 6 to 12 mm², right? So if you use the PLD itself, you can see it's only single device. And you talk about the size area is only 2.5 to 3. So it's definitely single device can do the job, and with a smaller PCB space. Right. So the other comparison is the what I call CAN arbitration application compare. So again, if you use the discrete function to implement this application, so basically you need to use 5 logics, and the area space talking of 44. So as compared to a TPLD, a single chip and the area space is much lesser. So in terms of BOM, is reduced by 80%. In terms of area, is 94%. Right. So that's where you can look at the value of using the PLD. Okay. So of course, to start with the PLD development, of course you need to get hold of this EVM. So this is the EVM we talk about. So we will provide you the EVM to do the evaluation, the programmer, and ultimately the what I call the interconnect studio. All right. So this is the interconnect studio that actually will allow you to do the design, simulate, and even program. Right. Again, it's free. You don't need to pay any money for this. And of course, the good thing about this is that it's real time and no coding needed. Right. Remember in the morning, Andrew talking about zero code. So right now, TI also going to all this kind of zero code. So no real coding needed, but more of a GUI, graphical user interface, right? So that it's easy to use for all of you. Okay, so this is a recap of the 3 devices I mentioned. So the 801, the simple one that come in SOT. So as I mentioned, our 801 also being an automotive grade certified. So we have a Q1 in SOT. Right, for the Chao1 in the VSOP as well as QFN. So for the automotive grade, the Chao1 only come with the VSOP packages. So Chao2, we have again 2 different packages, SOT and QFN. And of the Q grade is in the SOT23. All right, so this is for the PLD. So any questions before I change another gear to another different thing? Okay, so this will be, I think it will take me another 2-3 minutes. So I think you guys have been hearing a lot of API from TI. So whether you're R&D or procurement, so you'll see TI keep mentioning API everywhere. So what exactly is API? Right, so today I just want to give you guys a very 2 minutes walk through what we meant by API, all right? So basically API is, as the name defined here, is an application program interface. So I think for you guys in the software background, you know what's API, right? The software guy will definitely need to use this. So our API over here is actually the same. So basically it's a tool that we use to what I call interface between you and me, right? So you can see in this graphical presentation, right? So this is where actually is you are the customer, that you are making use of the API call to a library, and you get connected to TI. And then after that, once you're connected, you are able to get a lot of information out from TI. So this is what we actually telling the whole industry. We are embarking on the API to do various functions, right? So in the past, probably you have heard about this term called EDI, right? So EDI basically stands for the electronic data interchange or interface. So these are very old legacy system whereby you need to invest lots of money to get it enabled in your company to connect to TI to talk about loading orders. Right, you load the order to TI, we acknowledge the order, we do rescheduling. So these are the legacy tools that we use. And definitely the investment development is very high. So you need what I call an IT team to support that. All right. So of course it's a B2B, and the system response is very slow because it's run in batch. So normally when you send something to TI, it will probably take 2 hours back for us to acknowledge back your orders. So these are the so-called the legacy system that we will not recommend you to engage, right? So we are moving on to what I call API. So that as you can see from here, the EDI is one way, whereas for the API is bi-directional and it's real time. So in terms of investment, you don't really need to invest 500K to get a software. It's almost free. The investment you need is get hold of one of your software engineer from R&D to help you to do it. So this is what you need. That's why we say that development is low, it's B2B, and it's immediate. So this is what we are actually looking at, what you call the API, right? So this is the summary of what our API is all about. So on API, we have what I call 3 areas that we focus on. So number one, we call it the TI Store API. So what I meant is that basically, I think right now, if you're using Tech.com, right, you have to log in, manually buy certain part, log out, and so on and so forth. It's very manual. So with the API enabled, you can actually do it in a more efficient way, right? So it allows you to create orders, load orders, and also allow you to look at our inventory. So there's no need for you to log in to Tech.com to check whether is there stock for certain part. So using API, you can actually get the direct response from TI, right? So what you need to do is you subscribe to what I call the push, right? So whenever we have inventory of certain part, you'll get an alert from TI immediate, all right? Of course, you're also able to get shipping information, right? And also all those commercial invoice is all immediate. So this is for the TI.com e-store, right? So for the buyer, purchaser who actually load orders to TI, so we are talking about API backlog. So this is a system whereby your orders load to TI, we process it, we acknowledge it, and we also do all the various rescheduling, right? Of course, besides that, we're also able to provide the code. Right, sometimes you need a quotation. So using API, you're able to get a code immediately. And likewise, the same thing, you're able to get the shipping information, the invoices, and so on and so forth, all real time through the backlog. Of course, the other one, or what we call the product information API. So you're able to get a lot of information from TI. Instead of manually doing all the data sheet or some information search, you can actually using API to get information in a real-time manner. And of course, moving forward, you also want to integrate this PCM function into the API. Okay, so I hope you guys right now can at least get to know what is API from TI. Okay, so this is just a summary of what I mentioned. The 3 API areas we are looking at: product information, TI store, as well as the backlog API. Okay, so that's the end of my presentation. So, any questions?
TPLD, does it support the ABIL? ABIL, this is very old hardware description language. I'm using TPLD on my older work and wonder if TPLD is ABIL.
ABI.
ABEL.
ABEL. Wow.
So I think it's not. So it's a really old one. I'm having trouble finding the 16V8 TPLD now. So okay. I wonder if I can support the older work with your TPLD.
I will need to take the question down because I'm not an expert. I need to consult my expert whether do they support that particular function you mentioned about. Yeah, we'll take note of that.
But I guess it's not.
Yeah, never heard of it. It's a software tool or is a protocol?
It's a language.
It's a language. Oh yeah.
Hardware language.
No, we don't. Yeah. No, we don't support the language because we have our new tool. It's a brand new tool, so it's our own.
Yeah.
Yeah. So we don't support the own language. Yeah.
Any questions? Otherwise, it's time for lunch. I think you guys are very hungry.
I have a question regarding the API keys. Is it possible to connect API with SAP? And if we will able to connect it with SAP, how you will going to handle the backlogs and also when you are having push in and push outs? So how you will handle it through API keys?
I would say that there is no direct connection from the API to your SAP right now. So you need to create, I would say, a middleware to interface the API to your SAP, right? So I believe, I think we have our friend from SVI really encountered this issue, right? So they are running SAP, so they have the IT team to create the API to interact with TI. So that can be done. So we need to get your IT team to involve in doing the API interface to the SAP.
Okay, if we are able to do it, and how we will handle the consolidated shipments? You can consolidate the shipments through API or not?
Unfortunately, no. Because TI system, we actually ship per ESD. So we don't do consolidation of the shipment. So that portion is probably you need to work with your forwarder to consolidate shipment and then ship once to your company.
Okay.
So TI we don't consolidate. We ship per ESD per line item.
And how about the cancellation and rescheduling?
Well, there's no rules when you go into special rules that you go into API. So we still carry our very standard TI TNC. So right now our terms, I think probably you guys are not aware. So in the past, we are talking about always the 30 days reschedule window, 30-day cancellation window, right? So these are standard. So right now with TI, we are very flexible. So our cancellation and reschedule window can be as short as 14 days. So nothing changed.
Okay, thank you.
Sure.
Thank you, SC, for the presentation. We will have a break right now for lunch. It will be at level 4. Please follow our usher. They will guide you to level 4 for lunch. Thank you so much. Thank you.
Okay, thank you. The afternoon session will start at 1 p.m. Right, so you have 1 hour to enjoy your lunch. Okay, see you then.